Select the best vertex edge graph for the map shown. So here is a map of a neighborhood, and you can see that most of the intersections are labeled with vertices, A, B, C, D, E, F, G. And so when you're looking at the vertex edge graph, you want to make sure first that it has all those vertices, and second of all that the paths are correct. You want to make sure, for example, this particular map has a direct route from A to D and also from A to G. And so you'd want to make sure you have that in your vertex edge graph, that you have direct route from A to D and A to G, and just basically all the routes that you have on the map exist in the vertex edge graph, and there aren't any extra edges anywhere. So for example, the map doesn't show a direct route from A to C, so if you had one of those in your vertex edge graph, that would not be a valid choice. One way you might go about this is actually draw a vertex edge graph from the map and then compare it to these guys and see if you can find one that's like it. Maybe I'll just go ahead and do that, and then we can compare. So I'm going to make the graph shaped similar to the map. That'll probably be the easiest thing to do. So I'll just put vertices going along here, and then maybe C, and then B, A, G. Let's just label them real fast. F, E, D, C, B, A, G. And looking at the map, a road goes all the way around the perimeter. So I'm first going to just connect all of these, going around, making the perimeter of the map. Okay, and then any connections through the neighborhood, A goes to D, and G goes to E. And that's it. There's nothing from F to A or A to C or anything like that. Okay, now this vertex edge graph doesn't really have the same shape as any of these, but that's okay because it's an abstract representation. The only thing that's important is, are all the vertices included, and are the edge routes the same? Okay, so this one has a direct route from G to E and A to D. So let's see if any of these vertex edge graphs have that. Well, this first one doesn't have a route from A to D, so that one's out. So this one has A to D. It also has G to E, and it has G to F. It has F to A. Well, F to A doesn't exist over here in the vertex edge graph or in the map. So this one's out because it has an edge that doesn't actually exist. And that would be a problem because then you're saying, okay, well, this is a road that you can pass through, but you really can't because the road isn't there. Okay, next one, we have direct route from A to D and from G to E going across. And then let's just go around the perimeter also. So we have A to G, that's correct, and G to F, F to E, E to D, D to C, B, and then A. That goes all the way around. So this one actually seems to work pretty well. I mean, the shape is a little bit nicer than what I drew because it's a rectangle, but it represents the same thing. And let's just look at this last one here, and I can see right away this one also has the direct route F to A, which we already said was not valid on the map, so this one doesn't work either. And really all you need to do is find one way that the graph doesn't work, and it tells you that the graph's invalid. Okay, so that's the process for finding a vertex edge graph for a map. I just decided to draw my own graph and then compare it. But if you feel like you're comfortable going right from the map and then comparing the vertex edge graphs that are given, you can definitely do that too. Whatever method works better for you is fine.